Yeah, welcome everybody to our November edition of our seminar series in Digital and Public Humanities. So I'm very happy to introduce you to today's speaker, Alessandro Lenci, who is full professor in linguistics at the University of Pisa and the director of the Computational Linguistics Laboratory at the Department of Philology, Literature and Linguistics. He has extensively published on natural language processing and cognitive science. And his main research areas are distributional semantics and its application in linguistics and cognitive research, computational lexical semantics, computational models, and verb argument structure, and tools and resources for NLP. And in 2020, he received the 10-year Test of Time Award by the Association for Computational Linguistics. And his last main effort is a book on distributional semantics, published by Cambridge University Press in the series Studies in Natural Language Processing. Here and now, Alessandro Lenci will talk about challenges and perspectives of digital humanities and computational linguistics, and especially about large language models, which are the very basic at the very basis of the most recent developments in generative artificial intelligence applications such as ChatGPT that went through the roof most recently. And here is our expert for the development for these very powerful models. And we are glad to have you here today to learn more about it, and then have a discussion with people connected from home and here in the room. So please take use of the chat if you have questions, links, references, and then we will have an open discussion after the presentation. So thank you very much for being here, and the floor is yours.
Okay, thanks a lot for a nice presentation, nice introduction. Thanks everybody for being here at the top. So yes, so what I'm going to talk about is let's say that what is happening right now in computational linguistics, and what and to what extent the main changes that this field is undergoing in this period can also benefit the more general research in digital humanities. Okay. So in order to do this, in order to appreciate also the real, let's say, revolution that is happening right now, and it's better to see what was the common trend and the common, let's say, workflow in the digital humanities until let's say until now. So the typical workflow of the digital humanists. So basically, the idea was starting from some text collection in some, I don't know, could be history, could be some ancient language, whatever you want, literary work, and so on. In many cases, this type of let's say this resource was not digitized yet, so there was the need to turn into machine readable form by text scanning and on the OCR. But then OCR, it's noisy, and so we had to spend some time in correcting the OCR. And then, of course, there was the idea that, okay, once the text was digitized, let's annotate it, because we want to reach it with metadata for lemmatization, part of speech tags, we want to recognize proper nouns, or whatever other type of category we are interested in. And finally, of course, we want to use all these metadata in order to have to carry out some exploration, analysis, quantitative studies, especially if we are able to digitize a lot of text. Okay, so if that was the typical digital humanist workflow, I mean, what was the dream of the digital humanist? Okay, what was the ideal world if we could? I mean, if Erasmus could choose and to say, okay, I want to be digital. What is my greatest expectation? Well, first of all, of course, the idea is that I want to digitize as many text as possible. So, okay, of course, I mean, I want to have a lot of text, maybe big corpus. I'm working on a large amount of literary works. And especially, I'm working also with text genre of different types, or text belong to different times, or different languages, and so on. So that's also the typical scenario of a digital humanist. And of course, I want to automatize as much as possible this workflow that we saw before. Well, because time and money is limited. And in the humanities, we don't have many resources. And of course, correcting OCR by hand is very costly and expensive. And I want to, first of all, that my hope, my dream is that okay, thank you. My dream is that all the workflow could be automatized as much as possible. Ciao. Hello, ciao. And then, of course, the problem is that also, anyway, accuracy. Because my dream as a digital humanist is that I want 100% accuracy of the annotations. Because in many cases, every single example counts. Okay, because especially if I'm a philologist, I mean, I want to have a very high quality of the annotations. And in many cases, maybe the texts are not, the examples that I can deal with are not many. So, I mean, I cannot afford to have a lot of noise in my data. Okay, that's a big difference with respect to other type of applications in natural language processing, which, I mean, if you deal with something or social media or whatever, I mean, if you don't recognize, or if you have some noise you recognize in your tweets or your Facebook analysis, who cares? I mean, it's more the aggregated data that counts. But here, it's not the aggregated data. In many cases, it's the single item, single token that we are interested in. So I want to be as accurate as possible. Okay, so what the digital humanist will do? Well, let's ask the computational linguist and say, okay, what natural language processing and computational linguistics can do for me in order to solve these issues? And until now, I mean, what would be the typical answer of the computational linguist? I mean, of course, the computational linguist would simply answer with whatever, I mean, offering the digital humanist the best of the world that he can have. And basically, the typical answer until not long time ago would be something like that. Well, you know, I have several, dear Erasmus, I have several NLP tools that can be used for automatize your annotation task. And luckily enough, they are based not on rules anymore, but on machine learning tools. So they work pretty well. I mean, I know that the performance is good. But, however, I mean, be aware, because this performance is good, but it will surely deteriorate when I will apply it to your text. So to your data, because your data are very different from the ones that I've used to develop my tools. So, I mean, be aware of that. I mean, you cannot expect to have the same performance as the one for instance, I describe in my papers. And well, what we can do in order to do this? Well, just give me some good amounts of annotated data from your text that I can use to retrain my models. And in these cases, I mean, we will improve. Something good will happen, and the quality of the analysis will improve. And that's basically what was happening in large part of the digital humanities, or when we were involved in the digital humanists and collaboration in computational linguistics. Well, basically because we were used to work with the classical supervised machine learning methods to train our models, like part-of-speech tags, to annotate text, and so on, which basically were they needed some annotated corpus in order to be trained, and then that's allowed the model to develop a particular, the algorithm to develop a model to identify, to solve one specific task. And that's in fact the paradigm in natural language processing until now. So what we can call one task, one model approach. So for each annotation task, we needed a different model to be trained, and therefore new annotated data were necessary. Okay, so if you want to have your part of speech lagger, you need postal corpus. Then, okay, I want to recognize proper nouns, proper names, and classify other annotated with other semantic metadata. I need another model to do so. And typically, as I said before, these natural language processing tools were trained on text types very different from the ones used by the digital humanities. I mean, the standard corpora used for many type of annotations are contemporary web-derived text or journalist newspaper text annotated in some way. Okay, but typically all the state-of-the-art NLP tools have been trained on contemporary standard language of some sort, written language of some sort. And the other point is that in the digital humanities, annotated data are often scarce. So we don't have many, for instance, if we are working on some diachronic perspective, annotated data on, I don't know, Italian text of the 15th century are very scarce, very limited, very small amount of text are available. But one problem that these models had is that they generalize much worse when applied to out-of-distribution data. Namely, if you had your corpus, this means that basically, if you have your model that has been trained on text that are of the same type or the same language used. If you, for instance, they've been trained on a contemporary corpus. They generalize quite well to other text of the same type. But then, if you apply, for instance, to 15th century text, as I said before, the performance drops exactly because the new texts are out of distribution with respect to the data. So it contains, for instance, lexical items, constructions that never been observed before. And so, of course, these models do not generalize so well. Okay. Now, just to give you an example of this effect and how this affected also the process so far, so to speak. And I just can tell you about an experience that we had also with Federico when we worked together on this project, which is the construction of the Voce della Grande Guerra corpus, which is basically a corpus of text from the beginning of the century, so text of different types at the age of the First World War. Okay, so basically, that was a project that was funded by the initiative of for the first centenary of the First World War, and included people from the CNR. Federico has worked a lot on it on the digitization and the scanning and the OCR correction. Then there was my lab and the University of Siena and the Accademia della Tusca. And basically, this was really, a very classical instance of the workflow I showed you before. Okay, so there were digital, there was a certain amount of, no, I don't want to start anything. Okay, thank you. So there were, most of the text, I would say all the text were not digitized before. So they were just, we really started from the printed stuff. In many cases, the quality of the paper was very much deteriorated, and so there, as also Federico could witness, there was a lot of effort also in cleaning the text and so on. And then there was, of course, all the part of linguistic annotation I showed you before. And what we actually, the corpus is not huge, of course, because we're just 2 years of time. The funds were quite limited, as I said, another classical example. So, we couldn't hope to do, extraordinary things. So we were able to digitize 99 text and then annotated them with our tools, and then we also built an interface that would be also applied to other type of projects. But there were a lot of challenges in the sense that these text types were very challenging for this approach. Exactly because, I mean, text digitation was very noisy. So we started from, even from the scanning phase, was really problematic because there was a lot of noise. Although, I mean, Federico did fantastic job. I mean, putting all the state-of-the-art cleaning techniques and to enhance the quality of the scanning. But still, there was a lot of handmade correction. Okay, a lot. We also use state-of-the-art natural language processing tools, but all of these tools, as I said before, were trained on contemporary Italians. And the problem is that, I mean, there were a lot of differences in the language varieties and in text type with respect to standard contemporary Italian. It's not only a difference with respect to time. I mean, in the beginning of the 20th century, Italian was very different under many respects with respect to contemporary ones. But there were also very big differences in the text types. So there were orthographic errors due to low literacy. In many cases, we had to deal with letters from soldiers which were barely literate. There were substandard forms, archaic forms, dialectal forms. So a lot of things that were really problematic also for our tools. Just to give you an idea of the differences in the type of text we had to deal, on the left-hand side, we have a piece of text from D'Annunzio, where you can, I mean, you can recognize the high-level classic, almost poetry style of D'Annunzio with the archaic term like percote, which is, I mean, a non-contemporary spelling variations of percuotere and other lexical items that are like pico and so on and so on. On the other hand, a letter from a soldier, where you can see that it's completely ungrammatical under many respects. There are variations like tringee instead of trincee, trapazza, which is a dialectal item which has been imported into the text, and so on. So a lot of problems with respect to this. Well, I mean, what we did, I mean, of course, we had a lot of, as I told you, the resources were limited, so we said, okay, we scan everything we can, but actually only 1 million of the words, so it's a tiny portion of the original text were corrected manually at the OCR level. So this means that the OCR corrected forms is just a smaller amount of all the things that have been scanned, okay, because we didn't have time to correct everything by hand. And of this, it's an even smaller portion was also corrected by hand with respect to part-of-speech tags, and there were a lot of errors in this. Okay, so you can see that, I mean, exactly because of, I mean, of the difficulties of the text and the errors produced the instruments, I mean, all the things were shrinking and all the subsets were shrinking. So we were very far from the ideal world of annotating everything at the maximum level of accuracy. Okay, just to give you an example of the drop in the performance, okay, and the instruments. So just to give you an idea that, for instance, the NL processing tools that were used had a very high I score in F score, so high classification scores for sentence splitting, part-of-speech tagging, lemmatization, when they were applied to the same type of data they were being trained on, so newspaper articles of contemporary Italian. When the same tools were tested on text from the First World War period, the performance dropped in some cases of even the 30% of 15% of accuracy, which is a big drop. Okay, so it means that these errors, these systems made a lot of errors on this text. And of course, I mean, they made much more errors on the soldier letters with respect to the political speeches, because there were also all these substandard forms that they made their job even more complicated. So what we did, okay, the usual, I mean, workflow, we said, okay, we would take one of these, some of these items, some of these texts, we correct them by hand, we use them to retrain them, to retrain the tools. So this way, I mean, these tools were trained also on texts of the same age. So they weren't, I mean, the new texts were not out of distribution anymore. So at least some of the texts were seen during the training phase. And indeed, I mean, we were able to get an improvement of some sort. But still, I mean, there were a lot of errors produced by these models. Now, okay, so that's basically the story. I would say now it seems almost archaeology, but because I mean the things have been have changed so fast. But that's basically, it was almost yesterday in the sense that the project finished in 2018, so not a long time ago. Now, what happens if Erasmus calls our computational linguists now? Okay, not 2 years ago, not 3 years ago, but now. Okay, okay. The computational linguist answers, or say Erasmus say, what can you offer me to get my dream? And it's simply the answer now. It's simple. I have a large language model. Okay, so that's basically the typical answer that we can provide now in this model. So exactly because, and of course, I mean, when we speak about the large language model, okay, here we can speak about ChatGPT, but I mean, we actually speak about a bigger, a large family of models, but I mean, ChatGPT is just our, let's say, kind of top star, and just because it's easy to use, everybody uses, but I mean, so it's just an example among others. Okay, but why the computational linguist and why large language model can indeed be useful and indeed provide some help? Okay, because we have to analyze also the change in paradigm that these models have brought in the natural language processing, let's say, pipeline and way to address a linguistic task. So just to give you a quick idea of what we are talking about, well, we all know that when we talk about large language models, we actually talk about deep neural networks, transformers basically, which has been pre-trained on large amounts of data, but these data are completely unlabeled. That's the new thing. So no more, let's say, no more annotated data. They're just trained on unlabeled data. And then these models can be adapted to a wide range of different downstream tasks. Okay, so during the pre-training, the idea is that the network simply acquires a lot of knowledge from text by being trained as a language model. So by being trained simply to predict the next words given a context. And of course, in order to make this very simple prediction task, you don't need annotated data, because you just need unlabeled data, because the task is not to predict whether a certain token is a noun or a verb, but to predict whether a certain token is the one you expect given the context. So basically, you can compare the prediction of the machine against the actual token that follows that context, and using this as a supervision, backpropagation, and that's the way the network learns how to process. So basically, these models do not learn to carry out part-of-speech tagging or parsing on air. They just train and learn to predict the new words. By doing this type of prediction, given a context, these models acquire a lot of knowledge, a lot of linguistic information. That is what they can exploit then in tasks. Okay, just to give you an example of why we call them large language models. Well, of course, it's not only the size of these networks, which contains several billions of words, but you can see the trend in the corpus growth in computational linguistics and in data-driven approaches from the years 2000. So it's basically 20 years, 23 years, but you can see the growth. It's a log millions tokens, and that's basically, it shows that the growth. These are different type of distributional models. So somebody could recognize word-to-back or latent semantic analysis. But then you can see on the right top, BERT, the GPT-3, Palm, and so on, and you can see that it's going exponentially up. Okay. And in fact, I mean, if you think about the text that, for instance, GPT-3, which is basically the backbone of ChatGPT, has been trained on, you can see that it's almost 500 billion tokens, and just to appreciate, and all these are web text. Okay, so they basically use whatever they found on the web. So again, you can see, okay, but you know, we have all these models. We are trained again on contemporary text. How can they be helpful in order to deal with texts that are so different from web text, from what you find on the web? Okay, maybe they've also found some old texts that are on the web. Okay, so that's not a problem. But I mean, they still have been exposed, especially to text which is very far from maybe the ones that I mean, there's never no chance to be on the web, like for instance the ones that never been digitized before. And here again, you can see these are just a paper that also shows that, I mean, all these some of these models also use curated datasets. So it means that they use text downloaded by the web that have been slightly filtered and so on, but still is just massive amounts of text that are derived from the, basically from common crawl, so they are web-derived text. Okay, but what is the reason why these models are so interesting? Because it's true that they are, let's say, and what is also very interesting about these models. So the fact that, okay, these models have been trained on huge amount of language, but they are also easily adaptable to different tasks and different language types. So that's what makes them interesting. Okay, adaptable means that in fact, they are so-called foundation models. But you can see, instead of having one model to solve one specific model to solve each different task, we said, okay, I need to do part-of-speech tagging, I'm training a model. I have to do part-of-speech tagging of Latin, I take a corpus of Latin and I train it. Here I have just a gigantic model, which is then adapted in some ways to different type of application. And how do we make this adaptation? Well, one technique is fine-tuning. Fine-tuning means that on top of for instance, of the generative model, you have a kind of classical supervised model which is specialized on a certain task. But now this kind of classification layer on top of the generative model can leverage all the knowledge that have been that this model has acquired during the pre-training phases. And this means that the amount of label data that this model needs now is much less, just much smaller. So you need that this model can get better performance and good performance, even if then is presented with very little amounts, very small amounts of annotated data. Okay, so you need less annotated data, less tag data. But what's even more interesting, and the using of prompting. Prompting, what does it mean? It means that these models seem to be able to carry out tasks without being instructed specifically or being trained specifically for this task. Okay, so this is what are called emergent abilities. Okay, just to make a classical example, I mean, nobody has taught ChatGPT or these models mathematics, but he can do some mathematics. Okay, these models have never been specifically trained to translate, but they can translate. Okay. And that's the basic difference. So if you take the classical machine translation, you need to use a parallel corpus and to make specifically a model for machine translation. Now this translation ability is emerging from the general knowledge. This means that in order to solve a task, you can give this model a prompt, which basically gives it a very simple description of the task, which then the model is able to carry out. Okay, and I want to show you some examples and some, let's say, things that I've done with a very simple ChatGPT interface applied on digital text from digital humanities, and to see whether if they can be used, and to what extent they can be used to automatizing some of the things that I've shown you before. Let's start, for instance, from correcting OCR. Okay, so let's see whether these models and to what extent they can be used in order to make OCR correction. Okay, this is just an example. So that's a text from a war bulletin. So it's basically a text from 1915. Okay, and that's the original PDF source, and that's actually the result of the scanning and the OCR. And what I've marked here, let's see. Okay, what I've marked here are just in red all the errors made by the OCR. Okay, it's interesting. For instance, look at how it didn't recognize at all the signature. Okay, that was firmato da Ondi Revel, which was the chief of the Italian Navy at the time. And you see, there is really no identification at all. So then what I've done, okay, I asked the ChatGPT to correct it, and I simply use it okay, a simple prompt. Yes, I wanted to give you. Okay, that was the prompt. Okay, I said correggi gli errori di OCR nel seguente testo. That's it, and I give the text as a prompt, and this is what is done, and you can see that it has been able to reconstruct the model, the text, almost 100% correctly. Notice that also, I mean, the signature has been reconstructed perfectly. But it's interesting also because this highlights the problem of these models. That embeds. In the sense that, for instance, notice that the origin is gittarsi. When it corrects it gettarsi. Because, of course, we consider it as an error and gives us the variance. Lo stesso sieno, okay, it produces siano, which is perfectly correct. But on the other hand, the problem is that philologically might be a problem. You know?
It is a problem.
Exactly, it's a problem. Okay, and so that's also the things that we to do, and that's a classical example of the hallucination of these models that invents. But the idea was to say, okay, if it corrects OCR and it can be used as a spelling correction, is it possible to use these models to carry out linguistic annotations? And what is the quality of linguistic annotation? So linguistic annotations, of course, need to deal with meta-linguistic categories like part of speech or whatever. Okay. So the problem is that, so do the emergent abilities of large language model include also linguistic categories and meta-linguistic ones like part of speech tagging and so on? So is it able to do part of speech tagging by itself? And the idea is that, so can we simply use, I mean, train with very few examples, ChatGPT to become a part of speech tagger? Okay. And it seems that actually, I mean, there has been already attempts to do this, of course, and it seems that they got very, very interesting results. I mean, there is this recent paper, ChatGPT outperforms CrowdWorks for text annotation task. And they show that, I mean, this is basically, they didn't apply to part of speech tag, but applied to semantic categories like sentiment analysis and so on for political and sociological studies. And they say that basically the quality of the annotation is even superior to one that you can obtain from CrowdWorks. Okay. Now, on the other hand, I think that, I mean, asking to do some part of speech tags, it's even more complex than judging if something, for instance, is positive or negative with respect to the sentence. But again, it really deals to the linguistic category, so to the morphosyntax and so on. So, okay, so how can we teach to ChatGPT to do part of speech tag for us? Ok, that's the prompt. Fai il post tagging delle seguenti frasi, sapendo che i post tag sono, that's the list of the post tag. Degli esempi di post tagging svolto correttamente sono, and then I put two annotated sentences, and la frase di cui fare il post tagging è, and that's the text. Okay. And these are the sentences which have been derived from the universal dependency Italian treatment. So it's basically contemporary sentences. You can see Deutsche Telekom, Ameritech, and so on. But basically, the sentences were chosen in order to show the model at least an example of all the tags. Okay, but there were just two examples, two sentences. Okay, okay, that's basically it. So let's see what it does when it's applied, for instance, to our original text. Okay, that's the annuncio, just put in there. And you can see that basically, if you look at the part of speech tagging is basically perfect in the set. I mean, I was not able to find any type of errors, and it's really able to notice here again. Before it replaced sieno con sieno, but this time it leaves per tote. So it recognizes that per tote is a verb, though it's surely out of vocabulary for it. So it's very nice one, and it's interesting.
There's a mistake.
Where?
Del primo combattente.
Exactly. That's I'm going to.
Okay.
That's I'm going to tell you.
We know why.
But we know why. Exactly, because in this case it didn't do the tokenization, and then it's a preposition, of course, and it recognizes in this case not as the preposition but as the determinant. But no, that's in fact is a problem. Okay, here is the example of a sentence from a soldier. Again, you can see that again here we found some invention. So, for instance, ho, cutting in this way, which is being replaced by ho. But otherwise, I mean, for instance, missi, usually misi, it recognizes a verb and in a very perfect way. And here, on the other hand, again, it invents. So again, the problems come out. But you see, notice that what is important, is interesting to see, is how these models is able anyway to assign the correct tag, though the sentence is completely ungrammatical, and a lot of these forms are completely out of vocabulary in this sense. Notice that anyway it changes stringent and string. So again, the problem is as before, these models also do something that we don't want. So it's problematic to constrain, to force them to, and I ask different prompts. I ask you, say, okay, don't change anything, put again, and in some cases it does, in some cases it's not, and that's the problem. That it's a lot of unpredictable in the behavior. But still, I mean, look, I mean, two examples of a contemporary Italian, it's able to part of speech tagging almost correct perfectly the text. Now I said, okay, let's go a little bit older in the time, and I said, let's take Boccaccio, okay, and again, just the same prompt, different text. Here there is an error. That's again the problems that we were saying before. L'uomo, there is no tokenization, and so it identifies simply as the noun. In this case, instead of recognizing that it should be article and noun. And here there is an error, dea, perché facito l'idea principio, so it's dovere, should be a verb, but recognition it's noun. Well, al nostro novellare it classifies a noun, but it's a substantive. I mean, it's in between. Okay, it could be. I would say that even a human annotator might annotate it as a noun in these cases because it's a.
It is a noun.
Exactly.
It's an article.
It's a noun, exactly. So
there is a possessive adjective.
So it treats it like that. Okay. Quella, and notice that instead of quella udita, sono meravigliose. I don't remember. I don't know why I put it here. Anyway, and again, Dante, same stuff. Just put it to the beginning of the Commedia. That's perfect notation. Then I said, okay, what about if I put the prompt in Italian, but the text in Latin? And that's exactly, so the prompt was still in Italian. Okay, so it didn't see any Latin, it didn't Latin prompt. And then, well, that's not bad at all, I would say. Well, in some cases we can, here there is but even tertium here is really pronominal in this sense, okay? It's pronominal interpretation, so I think it's fine. And here I put at the beginning one sentence from the Vulgari Eloquentia. Okay, here for instance, tratta ec est nostra vera prima ec est a pronoun, while here, no, it's a more an adjective, okay? In these cases, si aliam sit esse locutionem, alia is not a pronoun, it's an adjective in these cases, it will treat as a pronoun, probably, but still, I mean, it didn't see anything like that. Now, then I said, okay, I want to say, but what does he know about linguistic categories? And I said, okay, let's do a trick. Let's build a kind of fake part of speech tagging, part of speech tags. Okay, you see, there are no more noun, verbs, and so on, because maybe I can say, oh, well, he saw, in some cases, he saw some part of speech tags. Maybe he really even took the universal dependencies from the web, and he learned that this noun is used as a noun. Okay, maybe he has taken some grammar books, whatever. So I simply replace all the tags with codes. A1, A2, A3, A4, A5. And of course, I show example in a proper way. So this means that now all the nouns are tagged not with the string noun, but with A8. And the determiner is not tagged with the determiner, but with A6, and so on. Okay, so it's just an invented tag set. There's no associations any longer to the classical post tags. And, okay, that's the beginning of the Promessi Sposi original tag set, original. And I mean, the part of speech as before, practically perfect. And here, it's exactly what we get when we use the fake tag set. And again, it is able to learn that it uses correctly A8 as a noun. So it's basically exactly the other one, but with a new tag set. Okay, so in these cases, you can see that, so again, the same error, there is treated as a determiner, so A6, A2, it was, A8 is a noun, you can see from here, catene, and so on. So it's a perfect part of speech tagging, but with tags it has never been seen before. Okay. So, well, of course, that shows that basically what ChatGPT does, it's simply purely distributional statistical learning. Okay, and so it doesn't know anything about noun and so on, but it does know, and it learns the distributional properties of this category. So it really learns the distributional definitions of these categories. Okay. And it's interesting that in this case, for instance, also the last experiment shows that it cannot be simply memorization. So, I mean, these tags I've never seen before. So it basically means that it exploits some knowledge it has about distributional similarities between nouns, and since in the prompt the noun has been associated with A8, everything which is recorded to be similar to that noun distributionally, it's assigned the same tag, whatever it is. Noun, A8, people, whatever. Okay. Okay, so this shows that surely large language models have some advantages. They're easy to adapt to new tasks and language varieties. They need limited amounts of annotated data. So my experiment was very simple, just 2 examples. I could have used 10 examples or 15 examples. Instead of using only Italian ones, I could have also used Latin ones, or whatever. But still, I mean, it's much smaller amount of data that one could have been used before. Now, of course, large language model has several limits. We have shown it before, hallucinations. That was one problem. I mean, sometimes they invent, and sometimes the invention is what we don't want, especially, again, if we want to have a very carefully, I mean, we don't want that, I mean, we want the text to be correct and not to be changed, okay, and so on. Stability. In some cases, correction occurs, in some others not. And so that's another problem. So sometimes their behavior is not predictable in this way. Okay, and that's maybe a problem. And of course, there is a problem as sustainability of these models. I mean, should I buy a license for ChatGPT? Okay, maybe I can use another language models like Llama and whatever. Let's hope that they are as good as the other ones and so on. So that's also a big issue. But surely, I mean, they can make the digital humanities happier in the sense that I think that they can be used also in this type of task. And they can, I mean, I think they can, they are also, although, I mean, they are usually applied to very different, very technology-driven applications and so on. But I think that they really have, they represent an opportunity for working in the digital humanities, exactly to speed up the processing of annotated text with a much higher quality and coping with the language and textile variety. So I think that digital, we don't, I really invite digital humanities not to leave all these things to the technology, in the sense that the digital humanities landscape should really be involved in what seems now to be a kind of a gold rush, right? So it's, I mean, seems that we have discovered a new gold mine and everybody's rushing to monopolizing it. But I think that digital humanities should really say their own word on this issue. And there are a lot of interesting examples of training or specializing language models for different language types, ancient languages, different text types, and so on. So there's a lot of things to be done in this area. Okay, thanks.
I have to admit, I didn't see the time passing so quickly, so that was really exciting, and we are really on the peak of the hype at the moment. So, and everybody is calling for digital humanists to intervene. So now it's the time to yeah, for what? That's a question. What can we do to improve ChatGPT or GPT and the models that are the basis for all these applications that are now on the market and further developed, so to keep pace. So that's open for the discussion now, I think. There's a question first for Federico and then from Belmonte. Yeah.
Yeah, I was very interested in the example that you showed in which the correction is a normalization, is a trivialization, okay, because this is a typical error that in which the Lectio Pacilior wins on the Lectio Difficilior, no? So I want to point out the importance of digital philology and in particular of the domain specialization. No?
Absolutely.
I guess that in this new era of computational linguistics, in which there are these largest models, the experts, the human experts, have even more importance to evaluate, but also to refine, to intervene, to work on it. So, yeah, so it is a golden age for digital philologists and digital humanists in general inside the larger domain of computational linguistics. I would know which is your point of view on this.
Okay, thanks, Federico. Yeah, absolutely. I mean, first of all, I would like to make a clarification. Okay, so I was not here to sell ChatGPT. I'm not paid by OpenAI. And so that's that. I wanted to be to be clear in the sense that I mean I think that these models have a lot of problems, and for instance, the one of overcorrecting. So lexicofascidio is a kind of overcorrection. Is really a problem. So in a way, we have to make them correct, but not too much. In a way, which is, I mean, not an easy stuff to do, but my choice of ChatGPT as an example was exactly what you can do even in a kind of a quick and dirty way with a kind of optical. A lot of things, as also Federico was saying, passes through specialization. Okay, so means that, for instance, using not so much prompting, but fine tuning on specific domain, on specific languages. So I mean, for instance, but the interesting fact that now, anyway, we can hope that the text or the amount of data that are needed also for this specialization are much less than the ones that were needed before, so to speak. So so that was a kind of a general introduction. Yes, I think I totally agree with you, Federico. It's important that we supervise this process at different levels. First of all, I would say also to ask and to learn to train and to use this model specialized for our own needs. So ChatGPT is hopefully is hoped. I mean, it was designed to do a kind of to become a kind of genius that comes out of the Aladdin lamp, right, and solves everything. You ask whatever you want, it responds. But I mean, that's what we need. Okay, I mean, if you want to have a large language model, we want to, for I don't know, doing some text analysis, we can specialize this for that. So we can invest on this. So, for instance, investing on having this type of models, maybe smaller ones, because we don't need huge models that knows everything, but smaller models to and I think that's also where we can and should intervene, so to speak. Okay. What I wanted to show is also the fact that exactly all this. I mean, it seems that nowadays artificial intelligence goes in one direction, and it's important that also the digital humanities go in a parallel direction. I'm not saying the same direction because different needs, but in a parallel direction, looking closely at what can happen on this field. And of course, being ready to say, okay, for my text, I need to have much more precision than others. And I mean, the precision of these models, the hallucination of this model is a problem in general. Okay, I mean, if you use these models for, I don't know, legal text analysis or medicine or whatever, I mean, we don't want them to be hallucinated. And also, this happens also when you present it to a text and so on. But it surely speed up the process a lot. I mean, that's something that cannot be underestimated. And I totally agree. I mean, we should govern the process, and it's even more responsibility for us to be ready to interact with them. Yeah.
We have a question from Rodolfo and then from the chat. So
going back to the very instructive case of the wrongly typed word del, which, as we know, it's an ambiguous word. It can be used as a partitive. Give me some bread. dammi del pane, it's a partitive, or it can be used as a prepositional articulated. Okay, so these two things, they can interfere. But now, let's go to the stochastic parrots, as Emily Bender called them. What happens? They have a layer where they encode positional information, okay? But they encode positional information in a statistical way. They would come out with the most frequent or the less error-prone choice, because it's always, it's not the best that they choose. They choose the less error-prone example. So this means that, and it's very strange, that this word has been used in this context, in a context where it has been used as a partitive, which is very strange. I mean, but there is something we don't know, because it's in the model. It's already there, and we can't modify that, because it's something that it's impossible to know. And the question is, how many of these cases are there? We don't know. So we will have to look back into the text that has been tagged and try to get the best out of it, because certainly it is useful to have one such tool and not to use it. It would be stupid not to use this tool. But then there's another question that I wanted to pose to you, that you've been using a very poor tag set.
Absolutely.
10 tags. Supposing now we double the number of tags, what is going to happen?
Absolutely. In fact, that's I mean, not only, I mean, another interesting, for instance, say would be to say, okay, can I train these models? Can I teach them to lemmatize? Because, for instance, for lemmatization is another important aspect for then retrieving the forms and analyzing. Okay. So, of course, that's in a way, I mean, 10 tags, it's an easy stuff. It's, I mean, so what about morphological inflections or whatever, and so on, of course. But I'm confident that anyway, the percentage of errors that it could make, even on a larger data set, provided you give them more examples, or for instance, and so on, it should improve. And I told you that was a really an extreme example. Okay, so just take it like that, give you an example what it does. Okay, it learns to use 10 tags. That's really something to be explored. I would say that's really, I would say that it's very interesting experience we can do about, I mean, I want to do some experiments, for instance, on lemmatization, where I expect really these models to fail in a way, although lemmatization is also a problem for humans as well. And so if you ask, for instance, a crowd worker to lemmatize normalize elements, I mean, how do you lemmatize per quote? Do you want to bring it back to per quote or not? Okay, that's a choice, which is also very theory-driven and a priori choice that we want to make. Okay, so this means that even if you think about the manual task, that's also a lot of there is a lot of subjectivity in this. Okay. So yeah, I mean, it's all what I'm saying. It's everything to be, because as you correctly say, I mean, we don't know really what happens inside them. So we don't really, and there is a lot of incoherence in what they produce. I think that anyway, what I'm really struck by is the fact that, I mean, everything in a way, digital humanities are a classical problem of transfer learning, in the sense that you have typically tools that have developed on a different variety of language from which you apply. Okay, because the languages or the variety that you want to apply maybe has little data, you don't have too many data. So we usually take tools developed elsewhere. So it's a problem of transfer learning. And these models are very improved. So that's something, then we can complain about many problems they have, but that's what they are very good at. And that's what we can exploit, because in the digital humanities, we really have a problem of transfer learning. So I have text from the 13th century that I want to annotate, and I cannot develop a part of speech tagging only for the 13th century. I want to start from another one, right? And so that's, I think, it's really the added value. Then, of course, with other problems.
That's an important question from Chantal. If you want to ask your questions, otherwise I can read it if you're not. Chantal Pivetta. Okay, I can read. So thank you for your speech. I was wondering if you only use ChatGPT or also other LLMs, such as open source ones, Llama, Claude, MPT, 7B, Falcon.
I mean, no, these experiments were really done on ChatGPT. Of course, I mean, for many other type of, I mean, I tend to use open source one. So I'm also very oriented towards these. For instance, it's true that we are doing some work with the Llama. On the other hand, it's much worse than the GPT family. There's some problems on it. But yes, I mean, that's also the directions I would use. I mean, of course, using open source ones like Bloom and others of Falcon, yes. But I haven't done the experiments yet, so yeah.
There's another question from Uskadir. Can you ask your question? Raise your voice if you're there. Uskadir. The audience is very quiet at home, so I can read again. Okay, thank you so much for this brilliant, inspiring presentation. What are your observations on the limitations of the context window? Have you checked its effects on PLOS, levetization, and OCR correction, especially in the masking experiment, replacing part of speech with codes?
I mean, the window, okay, I haven't understood, but there is no really window here. Perhaps you meant the sentence length or something like that. I don't know. I mean, because there is no really
meaning.
Huh?
No, not just one meaning. It can be how many words in one set.
Exactly.
How many?
Because there is, I mean, these models are really do not have any actual context window to fix, like in the classical part of speech, machine learning, in this sense. So no, I didn't explore this way.
Question for my daughter.
Always answer something to answers immediately. I mean the effect of consecutive prompts.
Okay.
Okay.
Yeah.
I mean the effect of the consecutive prompts. Okay, that's interesting. No, every prompt was a single one. So I started a new query for each single prompt in order to avoid any kind of effects from this. So I wanted to be sure for that. So even when I replaced all the part of speech tags, that was a really new query. I canceled all the others because I didn't want that it brought some memories of those.
That's interesting.
Yeah,
I thought the art to develop then the prompting is to get into conversation.
Exactly, but in these cases, I want to say, okay, is it able to post tag really from scratch with new tags that I've never seen before, with no conversation before? So that's why, yeah. So
that would really
thank you. Now I understand. Thanks.
That could really improve the results. So
exactly, or maybe you memorize that stuff and it project and so on. So no, I wanted to start with this.
As far as I understood, it also forgets what you said in the conversation. Exactly. You can't overburden with prompts in one go or in a series of prompts. Yeah, that's interesting. More questions from home or here in the audience?
Francesco Blanc.
Someone writes in. Very good. Yeah, Francesco, please go ahead.
So I have two quick questions. The first one, do you think beside this new very powerful neural model, large language models, do you think the old school models, so for example, the supervised learning can still play a role in our research? That's the first question. And the second one, do you would you recommend to use these models? I mean, even a large language model more through prepare software specialized for or not specialized for this task, or rather just to use the models through, for example, a script in Python or R? What do you think is the best practice for a researcher?
Okay, so the first question, very interesting question indeed. No, I think that the classical supervised machine learning is not that at all, in the sense that I think that it's going to converge with these models by using fine-tuning. So what I think it's probably over, it's the classical from scratch training of a classifier. Okay, so that's probably something which is over, because we have proven now, I mean, there is a lot of literature has shown that whatever task, if you first use these pre-trained models to feed the classifier with this pre-trained knowledge they acquire, the performance always increases. So the classical, I start, I don't know, support vector machine, I start with the annotated corpus, I train and I test and so on. That using some classical amount of feature, probably it's useful for explainability, for interpretability of the results. For instance, if you want to have some ideas of the features and what features are relevant.
That was exactly what I was thinking about.
So you see, if you want these, absolutely, no, because they are more explainable, more interpretable. You can do some feature ablation to understand which features are important. So, I mean, all these type of things stay. If you want to have let's say, optimize performance for a certain task, I would say, for instance, I think that the classical machine learning is going to be combined with the power that these models provide. Using these models as a kind of backbone, underlining a classifier is just like giving, I don't know, a 500 also an extra engine, right? So that's the idea, okay? An extra power, okay? In that sense, it's going to be changed. On the other hand, so and there are lots of applications for this. I mean, for instance, this experience of, I mean, you take, for instance, a language model trained on modern Greek, and you can then fine-tune it on classical Greek or on Byzantine Greek, and so on, with much less amount of text. So again, instead of training part-of-speech Dagger or whatever other models from scratch, you can use this. Second question, no, I think that the best way is to become as autonomous as possible. So don't use the things as an interface, learn to use to implement your API, use open source models, and so on. Of course, then the problem is also which type of models to choose. Now there has been a big distinction between instruct models, like ChatGPT, so models that have been empowered also with instruction-driven learning, which makes them more powerful because they are becoming a kind of chatting model, and you can use this prompting. But otherwise, if you have to use it with fine-tunings, why not using BERT or BERT stuff or BERT-like models? I mean, so we don't need to be always gigantic. Okay, so we don't. I mean, of course, it depends on the applications, but for our research area, you can have very good results with working on smaller models that you are able to tailor to your needs. I hope I answered to your questions.
Thank you very much. You have been very prescient and helpful.
Thank you.
Any further questions? Did you see it coming? So, I mean, this came as a sudden, or because you were already familiar with or participated in the creation of such models?
No, I mean, I didn't. I mean, I've been always working on much smaller models, like distributional semantics, and so on. Well, I think that I mean, I cannot say I saw it coming. I think that really the big difference was the scale up when they scale up these big models. And I think that this is something that nobody of us has seen, because it's something that is being done by very few labs in companies. And so basically, I would say that when GPT started with the prompting, it was already out of size for all of it. I think that I'm really, I mean, this afternoon I try to show you the best things that we can do with these models. But it's like using these models, like, I mean, who is not using machine translation nowadays to translate, I don't know, a letter, a document, a paper, whatever. Okay, I mean, what's wrong with it? I mean, you don't ask the professional translator to do it. You take Google Translate and you translate it. So I would say we should use these models in the same way, just instruments that are dull, are purely statistical engines, make a lot of mistakes, but speed up a lot of things without anyway trusting them so much. Okay, that's my basically philosophy to do this. And I, on the other hand, I'm ready to debunking all the mythology of these models solving everything and understanding everything. That's just stupid thinking and simplistic thinking.
There's another comment from Ustadir, not a question, but a comment. While LLMs can be a crutch, using LLMs for correction OCR seems fantastically time-saving idea. We'll try it as soon as possible. Thank you. I also posted a link to a call for experiments that some colleagues of mine in Germany, so the call is also in German, for the next DH conference in the German-speaking countries about the use of large language models for text encoding, scholarly editions, but that includes also the polishing of OCR results. So, and also then at the very end, also linguistic annotation. So it's can be one long chain of
absolutely. So
and making
as you said, I mean, for instance, I mean, these models are very good at generating code. When you encode the text with XML or whatever, you are doing coding. And so, I mean, why not use it for speeding up this work? Yeah. So, in that sense, I would say that probably, I mean, digital humanists will benefit from them much more than purely linguists, in a way, in the sense that there will be useful tools to solve a lot of practical issues in corpus encoding, corpus annotation. So, I'm thinking also not only about history, thinking about all work on substandard variants of a language, or spoken language, or language from minority, whatever. I mean, whatever we have very little data, these models can help to speed up the process. And then maybe when we build enough data with this same automatic processing, doing some corrections in order to, because we don't trust them too much. So if you do some correction, then we can leverage on the new data, and we maybe come back to good old school models that maybe can be more interpretable and so on. So I think there is a lot of new things that these models can do, and for this specific application.
If you want an anecdote, if you want, just to make ChatGPT fail, how do we make ChatGPT fail? Badly fail, using poetry. This is something I'm working on lately in the last 5 or 6 years. So you can ask ChatGPT to produce a poem on a certain topic, and then you get the poem. Then you say, I want it rhyming like a sonnet, and then it comes a sonnet. Okay, so it obviously the poem is very stupid, so it doesn't have a real issue, I mean, on the topic. But anyway, then you make it a little bit more complex, because that's what ChatGPT is unable to do. To have a complex task where it has to go from one point to another one, and then up on the other 2 points. And then I asked, can you make a poem using enjambments. Enjambment, as we know, requires linguistic knowledge. You need to know that the end of a line is not the end of a sentence. In other words, the meaning goes on to the other line, on the following line, which is something that requires syntactic knowledge, failure, total failure. I said, no, okay, not enjambment everywhere, just do enjambment at stanza level. So knew already that at the end of a stanza, it could do the enjambment. No way, no enjambment at all. And he has been trying, but that's just to give you an example, that the complexity makes it impossible for these models to be able to act on top of previous knowledge that it has to give. So, just an example, as we know, I mean.
I have one final, because we talked about failure and errors and functionalities or making it functional. We didn't talk about biases, and I think that's a huge issue. Any comments about this, how to deal with it? That's again where digital humanists, I think, are, or the humanists are called to show and point to the weakness and the problems as regards biases in the semantics and the reproduction of patterns that are not desirable. So,
yeah, absolutely. And the point is that, that's a very difficult issue in the sense that, I mean, ChatGPT was exactly designed in order to solve this bias problem, right? So basically, it's, I mean, all the effort that they made with reinforcement learning was exactly to reduce the amount of bias. The problem is that then in some cases you compromise its possibility, in the sense that if you use a word that is considered to be politically incorrect, I mean, it doesn't solve you a problem simply because it's unpolitically correct. Is that we want? Well, no. Okay, we would like the model to be unbiased in the decisions that you make. But in a way that is not kind of censor with respect to the type of knowledge. I think that, well, again, the one possibility would be to, okay, also the work in distributional semantics and word embedding and so on, I mean, there's been a lot of research on biases even there, and basically a lot of attempts to eliminate or reduce the biases, and these biases anyway are so strong that they are hardly can hardly be cancelled downstream. So the problem is, again, probably on the text we are going to train these models. So are we sure that the best way is just taking all the text that we want to take? And that's why also, for instance, OpenAI is investing so much time in cleaning the text, separating the good ones, the bad ones, and so on. Okay, because that's probably, well, I mean, you don't want to teach your kid to read by reading anti-Semitic books, right? So, of course, I mean, then if it reads only these books, it's very likely that it will be grasp some anti-Semitic concepts. So we don't want these models to be trained on whatever text it takes. So we are going to clean them. It's a costly enterprise. So in order to clean the text in Falcon, they spend more than 1 year and a lot of resources, some human resources to do this. But they were in Qatar and they have a lot of money to do this. And that's so, yeah, that's a very big problem with a very difficult solution. So.
Yeah. But will they be able to keep pace with the development who just don't care?
Okay, that's another issue. That's a political issue, an ethical issue, and unfortunately, there is the risk that this big monopoly of these few companies is so powerful will prevent efforts to control. And for instance, the AI Act that is going to be discussed is exactly this. I mean, you know, if you have read, for instance, Germany and France are more oriented towards a kind of liberal attitude. I mean, no, foundational models shouldn't be controlled because they should be able to self-regulate and so on. And Italy seems that it wants to follow that. We also, as a community, have tried to, on the other hand, has written actually a mail, that is a letter that's been circulated in the community, trying to say, no, rules are important because these companies will not self-regulate. That will not be enough. Okay, so we must put some limits on what these models, on how they are trained. That it must be clear on which data are being trained, and so on. Okay.
Okay. Thank you very, very much once again. Thank you very much again, Alessandro.
It was my pleasure. Thank you.
We meet again in the context of our seminar series in 2 weeks already, on the 13th of December. There will be Rosanna Damiano from the University of Turin, and she talked about storytelling as citizen curation in the SPICE project. The role of emotions and values to promote inclusion. So see you back here and have a nice evening.